Hello and welcome to another one of my videos. In this video I'll be walking you through a question from the Edexcel GCSE Maths practice paper where only 0.2% of students achieve full marks. So Uma thinks that a plus 1 all squared equals a squared plus 1 for all values of a. Part A, show that Uma is wrong, so this is 2 marks. So we just focus on this left hand side here. So we've got a plus 1 all squared. So we just expand this. We're going to get a squared plus 2a plus 1. So straight away we can see that left hand side is not equal to the right hand side. So we just write a squared plus 2a plus 1. It's not equal to a squared plus 1 for all values of a. Therefore Uma is wrong. Okay, so that's part A done now. So let's move on to part B. Here are 2 right angled triangles, all the measurements in centimetres. So we've got lengths A, B and C on triangle 1. And on triangle 2 we've got lengths A plus 1, B plus 1 and C plus 1. So right angled triangles. So this straight away makes us think, okay, Pythagoras theorem. So we just write it down. So by Pythagoras, we know that c squared equals a squared plus b squared, where c is the hypotenuse, and then your a and b are opposite and adjacent lengths. So we just apply Pythagoras' theorem on triangle 1, we get c squared equals a squared plus b squared. So let's just box this and call this equation 1. So if we apply Pythagoras' theorem to triangle 2, we get that c plus 1 all squared equals a plus 1 all squared plus b plus 1 all squared. So we just expand this. We get c squared plus 2c plus 1 equals a squared plus 2a plus 1 plus b squared plus 2b plus 1. We just tidy this all up. So I'm going to move my 1 over to that side as well. So we're going to have 2 c squared plus 2c equals a squared plus 2a plus b squared plus 2b plus 1. Because those two are going to give me a plus 2, then I'm going to subtract 1 on both sides. So I'm just going to box all this up and call this equation 2. So now if I sub equation 1 into equation 2, we're going to get equation 3, which is going to be, so we're going to have a squared plus b squared instead of this c squared here to get a squared plus b squared plus 2c equals a squared plus 2a plus b squared plus 2b plus 1. Now we can see that we're going to have a plus a squared and plus b squared on both sides. So we subtract a squared plus b squared on both sides. That's going to leave us with 2c equals 2a plus 2b plus 1. And that's exactly what's required in the question. So all we have done, so we have done Pythagoras' theorem on triangle 1, Pythagoras' theorem on triangle 2, then we have substituted what we found using triangle 1, so c squared equals a squared plus b squared, put that into the Pythagoras' theorem equation that we've got from triangle 2. Then once you just tidy all that up, we get what's required in the question. Okay, so part 3, a, b and c cannot all be integers. Explain why. First of all, what is an integer? So that is a whole number, and so it's not a fraction, okay? So if we say, so if a is an integer and b is also an integer, and we use what we found in part B, that 2c equals 2a plus 2b plus 1. So let's just tidy this up a bit. Let's divide by 2. So we get c equals a plus b plus half. So if we've written that if a is an integer and b is an integer, then this here, c, cannot be an integer. So that's because we've said if a is an integer and b is an integer, that means that this here must also be an integer, because when you add 2 integers, they'll also give you an integer. Then we've got an additional half here. So we've got a whole number and then we're adding another half to it. That's not going to give us a whole number again. That will give us a fraction. and so c cannot be an integer if a and b are integers. Thank you very much for joining me in this video. I hope this helps and I hope to see you in my other videos. Goodbye.